A wheel initially at rest rolls without slipping down an incline for 4 seconds. The final angular velocity of the wheel is 5 pi radians per second. How many revolutions did the wheel complete? How to find the number of revolutions? It's just an angular displacement divided by the angle of one revolution, which is 2 pi. So the angular displacement should be found, and since time is given, the initial and the final angular velocities are given. The next formula can be used, and it says that the angular displacement is equal to the final angular velocity plus the initial angular velocity divided by 2 and multiplied by time, and we get that it becomes 5 pi plus 0 over 2 times 4, and it's what? It's 10 pi, and hence 10 pi divided by 2 pi, we get that it is equal to 5. So 5 is the required number of revolutions. The next, what is the unit of angular impulse? The linear impulse, it's from the formula that impulse is equal to change in momentum, and it's force multiplied by time. And for angular, instead of force, it becomes just what? Torque, or moment of force. So it's force multiplied by distance and multiplied by time. And you can see that not SI units required here, since we can see that Newton remains, and force is measured in newtons, and hence it's already Newton, and it must be additionally multiplied by what? Distance, which is measured in meters, and by time, which is measured in seconds. So it becomes Newton meter second is D. The next, a car of total mass capital M is traveling with constant speed v. Each of the 4 wheels of the car has a mass m and a radius r and rolls without slipping. The moment of inertia of which wheel is a half m squared. What is the sum of the rotational kinetic energy of all 4 wheels to translational kinetic energy of the car? Translational, it's what? mv squared over 2, and m, it's this capital M. V squared, it's the linear speed of the car. And the sum of the rotational kinetic energy of all 4 wheels. So it's 4 multiplied by the rotational kinetic energy of 1 wheel. And for rotational kinetic energy, formula is given in data booklet, and it says that it's what? I omega squared over 2. Omega, it's what? It's linear velocity divided by radius and squared. And I, it's a half m r squared. R squared cancels, and it becomes mv squared over 4. mv squared over 4. 4 cancels, v squared cancels, and it becomes what? 2m over capital M. So it's C. And that's all for this question.